This is the first, last, and only video from section 4.6, Integrals of Vector Valued Functions. And so far, a lot of the things we've looked at with limits and derivatives, tangent lines, everything has pretty much worked out the way we've expected it to work. And so we're not too surprised in section 4.6 when we integrate a vector valued function, we simply integrate each component function. So if f is the vector valued function xt, yt, zt, then the integral is simply the integral of each component function. And again, in the notes, I wrote f goes from r into r3, but this is really v3. And again, nothing special about 3. It's just usually we work in v2 or v3. But this concept carries on to v sub n for any n. It's just however many components we have along here. It's just usually 2 or 3. So we'll do a couple of examples. We have the integral from 0 to 2 for our first example. Our second example is an indefinite integral. What did we learn in Calculus 1 and Calculus 2 about definite and indefinite integrals? In Calculus 1 and Calculus 2, we learned that a definite integral is a number and an indefinite integral is a function, or more precisely, a class of functions. For Calc 3, when we integrate vector valued functions, a definite integral is going to be a vector as opposed to a number, and an indefinite integral, again, is going to be a vector valued function, or actually a class of vector valued functions. So we integrate 0 to 2 of this vector valued function. I wrote it in the notes a little bit differently. I wrote this as 3i minus 5it squared, or minus 5t squared j. Is how I wrote that in the notes. But we just find an antiderivative of each component. So we have 3t, negative 5/3 t cubed. We're going to evaluate this at 2, evaluate it at 0, and subtract. So evaluate it at 2, evaluate it at 0, and subtract, and we have a vector. When you calculate the definite integral of a vector valued function, you get a vector. When you calculate the indefinite integral of a vector valued function, you get a vector valued function, or actually a class of vector valued functions. So here we integrate 2t sine t e to the t sine t. Component-wise, antiderivative of 2t is t squared. Antiderivative of sine of t is negative cosine of t. Antiderivative of e to the t times sine t, that was a fairly lengthy Calc 2 problem, if you recall. You do this with integration by parts. It's one of those problems where you apply the parts formula, then you apply it a second time, and then you solve for the integral. And so if you want a refresher on how to do that, you can ask me in class in the week when we are looking at this section. So I will remind you how to calculate this integral if you ask. But the antiderivative of e to the t times sine t is 1/2 e to the t multiplied by the quantity sine t minus cosine of t. And so we have this vector valued function here. In Calculus 1 and Calculus 2, we would add an arbitrary constant, do the same thing here, except our arbitrary constant is a vector because this is a class of vector valued functions.